Welcome back, ChemStars. It's Ms. McCauley bringing you page 2 of your Chapter 12 homework on solutions. This is page 2 for both Level 1 and Level 2 Chem, and this is a really good prep for our Glencoe Virtual Solubility Lab, which will be coming up later. Okay, so this is new Chapter 12 content. There's a little bit of it in your video notes. We're going to be answering questions based on the solubility curve at the right. Okay, so this new thing is called a solubility curve. We've got a chart over here, and let's just break down what goes on each axis. So on the x-axis, this got cut off on your page, but these are going to be, this is the temperature. So if you want to just label this right now, this is the temp, and it's in degrees Celsius. So it goes from 0 to 100, so freezing to boiling. So x-axis is temperature. And then the y-axis that we have right here, this is the solute per 100 grams of water. Okay, now what that means is that we're keeping the volume of liquid in the container the same. And so it's always going to be like, imagine you had like 1 cup of liquid, we're going to see how many spoonfuls of sugar we can stir and dissolve. But it's not going to be sugar, it's going to be all these different chemical compounds. So the per 100, this just means that we're keeping it constant. Okay, so this right here is a constant, and we're going to be looking at how many grams of Ki, KNO3, NaNO3, how many grams of those different salts can be dissolved. Let's look at some general trends. What do you notice? In general, as temperature goes up, what are most of the lines doing? Most of the lines are also going up. So the warmer the water is, the more stuff can be dissolved in it. And you know that's true if you've made homemade rock candy or homemade fudge, or you've stirred your hot tea with sugar in it. But that's not always true. Do you see that there's actually some compounds that they decrease in solubility with how warm it is? And some of those compounds actually aren't salts. So like SO2 becomes less soluble, that's a gas. NH3, ammonia, less soluble. HCl, a gas that makes hydrochloric acid when it dissolves, less soluble. But pretty much for all of the salts, and remember a salt is a metal cation and a non-metal anion coming together to make an ionic solid. Those pretty much all increase. Some of them increase really linearly and predictably, but some we see more of an exponential growth curve. And then there's one weird one right here. Look at what's going on with NaCl, regular table salt. What would you call the slope of that line in math class? You would say it's pretty flat, or the slope is kind of 0. So if I heat up water, table salt doesn't actually dissolve better the warmer it gets. Table salt has a pretty flat solubility curve. So we're going to use this graph, this solubility curve, to help us answer all these questions. So let's start with number 1. Number 1 says, which salt is least soluble and which salt is least soluble at 20? So over here, we're going to go to 20, and we want to find the salt that's least soluble. You'd think, oh, one of these two, but check the label. SO2 isn't a salt. But the next one, it's right here, KClO3 is a salt. So the salt that is least soluble is potassium. Oops, wrong pen right there. Let's get the right one. Potassium, KClO3, potassium chlorate. That's the least soluble salt because its line is right here. It's actually lower than the SO2. So potassium chlorate. Question 2 says, how many grams of potassium chloride? So let's find the potassium chloride line first. So that's going to be KCl. So here's my KCl line. I'm looking at this curve. Can be dissolved in 100 grams of water. That's just kind of a distractor. It's telling you, yeah, we standardize that at 80 degrees Celsius. So we got to find 80, and we got to see where that intersects, right about here. So let's read the intersection here. So 80, this line is right about here. Okay, so if this is 50 and this is 60, what do you think that is? 51 grams? Maybe 52 grams? If you told me 50 or 53, I'd say no. Somewhere around 51, 52. That's per 100 grams. Now, this next question, we got to just think about a little bit carefully. We're keeping the temperature the same, but they doubled the size of the pot. They doubled the amount of water there is. So just think logically. If you can dissolve 51, 52 grams in 100 grams, what if it was 200? What if it doubled? Take a second and think. What should the answer be? If you said 102 to 104 grams, you're correct. We just double it. If there's twice as much water, you can dissolve twice as much stuff. So I'm going to make a little note here. 2 times as much water, that's the solvent, you can dissolve 2 times as much. Okay, keep that in mind. That'll be important later. Question 3, at 40 degrees Celsius, so let me get going on this one here. At 40 degrees Celsius, how much potassium nitrate can be dissolved in 300? So we got a couple tricky things here. What we're going to do first is we're going to say, okay, let's just say, oops, wrong one here. So let's get it at 100. That's what my graph says. So at 40 degrees, so 40 degrees is right here. They want to know potassium nitrate, KNO3. Now, potassium nitrate's up here. So here's my potassium nitrate line. I'm tracing that down, and I want to see where it intersects with 40. So right about here. Here's 60, here's 70. I'd say 65, maybe 64. Kind of hard to read. So at 100, it's 64 to 65 grams. Okay? That is not the answer, because they want to know if I have triple the volume of water. So what did we say before? 2 times as much water, dissolve 2 times as much stuff. This time we have 3 times as much water. So how much can we dissolve? 3 times as much stuff. So take out your handy dandy calculator of science, and let's take 64 times 3. That's going to be 192. And let's say maybe it was 65 times 3. Somewhere between 192 and 195 grams. That's my final answer. So my chart is only for every 100 grams of water. So if they have 300, just triple everything. Okay. Next one. Which salt shows the least solubility? Let's pick another fun color. Oh, why don't we try orange? The least change in solubility from 0 to 100. So we want to find the flattest slope. We already talked about that. Sodium chloride, regular old table salt. And oops, that was bad color to pick. NaCl. The slope is almost 0. I know it's not quite 0, but it's really flat. Okay. Question 5. At 30 degrees C, 90 grams of sodium nitrate, so we're looking for sodium nitrate, is dissolved in 100 grams of water. So let's just find that sodium nitrate, NaNO3. So here's my sodium nitrate for that problem. And they said that at 30 degrees Celsius, 90 grams dissolved. So let's just check my chart. 20, 30. This is my little 30 line. Okay. Oops. No, that's the 30 line. Okay, so this one right here, this line is 30 degrees. And they want to know, is the solution saturated, unsaturated, or supersaturated? Before I get to that, let's look how much can I actually dissolve at 30 degrees. So here's that sodium nitrate line. We want to see where they cross. They cross right here, read across, and I'm just going to call that 95. I think that's good enough. So we can dissolve up to 95 grams at 30 degrees. But what does the question say? It says there was only 90 grams dissolved. Is it saturated, unsaturated, or supersaturated? Go back to your notes or check this little reminder here. These lines are the saturation points for the different salts at their temperatures with the same volume of water. So if we are exactly on the line, it's saturated. Was our point on the line? No. If it's above the line, it means it's oversaturated, it's supersaturated. Where were we? We said that it could dissolve 95, but someone only actually dissolved 90. So we're right here. So we are actually unsaturated or undersaturated. Okay, so for this question, I'm looking over here, and we were below that line, so we are actually unsaturated. We could dissolve 5 more grams at this temperature. So there's still some more room to dissolve. Okay. Next one here. A saturated solution of potassium chlorate. So what that just told me right now is that we're going to be on the line for potassium chlorate, is formed from 100 grams of water. Okay, so we can use the chart. If the saturated solution is cooled from 80 to 50, how many grams of precipitate are formed? let's kind of work through that together. Potassium chlorate, saturated, starts at 80, goes to 50. So let's say at 80 degrees, we're going to see how many grams it can hold. And at 50 degrees, we're going to see how many grams can be held. So 80 and 50 for potassium chlorate. Potassium chlorate is KClO3. So we're looking at this line. I'm going to outline it in blue here. That's our KClO3. And here's 80. So let's read that point. I don't want to call that 55. I feel like that's probably more like 54. So at 80 degrees, we can hold 54 grams. Then at 50 degrees, we're at a shade over 20. Let's call that 21. Now, if you're plus or minus 1, I'm okay with that. So 54 and 21. What happens is I go down this curve and I cool it. The precipitate actually starts to form on the bottom of the glass. If you ever have had iced coffee and you stir in extra sugar, it gets all crunchy on the bottom. That sugar has precipitated or just stayed stuck on the bottom. So what's going to happen? How do we find this out? Well, we just got to find the difference between those two numbers. So if I started with 54 and only 21 are left in the solution, that means 33 grams precipitated or rained out. 33 grams, that's our final answer. Okay, now this next question, it says, which compound or what compound shows a decrease in solubility? Now it says compound, so that could be anything, including a salt. So from 0 to 100, which ones have a negative slope? There's a couple different answers here we go with. So anything with a negative slope. We see HCl goes down, we see NH3 goes down, and we see SO2. Any others with a negative slope? No, I don't think so. So we'll say all of those. A decrease in solubility could, HCl, could be NH3 ammonia, or it could be SO2 sulfur dioxide. Now, if they want to know which salt, then we'd have to technically say HCl. It's more salt-like than the other ones. Now, this next question, they do say which salt. So it has to be a metal and a non-metal, a cation and an anion there, is most soluble at 10 degrees. So let's go up to our chart, find 10 degrees. Which one's the highest, most soluble? Oh, you're like, oh, maybe it's NaNO3, but you've forgotten potassium iodide. Super soluble. It's off the charts here. Potassium iodide is very soluble. So the most soluble salt at 10 degrees is, my touch screen keeps jumping here, is Ki, potassium iodide. Now we want to know which salt is least soluble at 50. So the lowest salt, remember, we're looking for a cation and an anion there, least soluble at 50. So here's 50. You're thinking, oh, SO2, but SO2, not a salt. At 50, KClO3. That's our least soluble salt right here. It's the lowest amount of grams that can be dissolved. So at 50 degrees, this line is KClO3. And one question left. Which salt is least soluble at 90? Now they're saying salt again, so we gotta look for that cation in that anion. 90 degrees, least soluble salt. So here's 90. Okay, SO2 not a salt, ammonia not a salt. 90 degrees, sodium chloride, good old table salt. Okay, so we've worked through understanding how solubility curves works on this page, looking at if it's on the line, it's saturated. That means it's perfectly holding as much stuff as it can. If you go above the line, it's super saturated. There's too much stuff in the solution. It will start to precipitate out. And if we're under the line, it's unsaturated, meaning you can add more in. So if you're having any problems, make sure you go back to the video notes, email your teacher, and this will be a really good prep for that Glencoe Virtual Solubility Lab coming up. Thanks, guys. Don't wait to be great. See you next time. Bye.